Welcome to Math with Mrs. Bibb. This week we will be solving quadratics by factoring again. These problems are on Student Journal, page 243. Remember, to solve a quadratic by factoring, the first thing that must be true about it is it must be equal to 0. And as you look at number 17, it is equal to 0. So I am going to look at that quadratic and see if it has a common factor. And as I look at that, I notice that they all have 3 in common. So I'm going to take out the common factor of 3. I am going to name A, B, and C. I'm going to make a table. A times C, sum of B, and that would be 2 negatives, so negative 2 times negative 5. I'm going to bring down this 3. A is 1, so I can factor this the quick way, where I put my x in the first spot, and I take this negative 2 and put it in this spot, and this negative 5 and put it in this spot. Now I'm going to do the zero product property, where I set each factor equal to 0, and I solve. I have to throw this one out because 3 can never equal 0. I want to remind you that I am modeling to you how I expect to see your work. So my solutions are 2 and 5. That looks like negative 2. Okay, got it. So 2 and 5 are my solutions. Okay, let's go on to the next one, number 18. As I look at that, I notice I have a greatest common factor of 5. Divide each of these by 5. Oh, it does equal 0 too. I should say that, I guess. Y squared minus y minus 6 equals 0. A is 1. B is negative 1. C is negative 6. Bring down my 5. Make a table. A times C is negative 6. Sum of B is negative 1. I need a negative times a positive. Oops. And I just goofed that up. Hold on. So I need a negative times a positive. I need the bigger one to be negative, and that's what works. So y plus 2, y minus 3, bring down my 5, y plus 2 equals 0. Whoops. Sorry about that. Let me erase. Oh. I'll get the eraser eventually. Maybe. That's so strange. I'm kind of stuck on that. Okay, finally found the eraser. Sorry about that. 5 equals 0. Y plus 2 equals 0. Y minus 3 equals 0. Subtract, 5 cannot equal 0. Subtract 2. Y equals negative 2. Add 3. Y equals positive 3. So my solutions are negative 2 and positive 3. Now we're about to encounter for the first time one that is higher than a quadratic. I want you to notice that the largest exponent or degree here is 2. The degree here is 2. And there are 2 solutions. 2 solutions. The degree here is 4, which means that there are going to be 4 solutions. Now 2 of them may be disguised, but I'll show you what I mean by that. So first I'll do a greatest common factor of c squared. I'll divide both of these by c squared. So c squared minus 81 equals 0. And this is a binomial that is a difference of squares. So I'll bring down the common factor, put 2 empty binomials, put an addition sign in one, a subtraction sign in the other, and take the square root of c squared and the square root of 81. Now I'll do the zero product property. C squared equals 0, c plus 9 equals 0, c minus 9 equals 0. I would take the square root to solve this. So c would equal 0. And now this should be 2 solutions based off of the degree of that, but 0 is the only number that you can multiply by itself and get 0. Then I'll subtract 9, c will equal negative 9, and add 9, c will equal positive 9. So my 4 solutions, 0 is called a double root, or negative 9, that's 1 root, 0, that's 2, and 9, that's 1 more, so that would make 4. So sometimes you'll have more than 2 solutions. Carrying on, number 20, I noticed does not equal 0, so I am going to subtract 9d and subtract 9. That would give me 0 over on the left-hand side, and that would leave me d cubed. I'm just going to put it in descending order. D cubed plus d squared minus 9d minus 9. I have 4 terms, so I'm going to factor by grouping. Group the first 2 together, put a plus sign, group the last 2 together. I'm going to take out d squared, and that will leave me d plus 1. I'll take out negative 9, and that will leave me d plus 1. Then it did work because this and this are the same thing. So I have d plus 1, whoops. I have d plus 1 times d squared minus 9. And I notice that I have a difference of squares. So I'll bring down my 0, I'll bring down my d plus 1, I'll put 2 empty binomials, one with an addition sign, one with a subtraction sign. I'll take the square root of d squared and the square root of 9. And then I will do the zero product property. D plus 1 equals 0, d plus 3 equals 0, and d minus 3 equals 0. Subtract 1, d equals negative 1. Subtract 3, d equals negative 3. Add 3, d equals 3. So my 3 solutions are negative 3, negative 1, and positive 3. So notice the degree up here was 3, and I have 1, 2, 3 solutions. Okay, moving on to the next one. I notice I have a difference of squares, so I am going to put, I don't have a difference of squares. I'm sorry, I have a common factor first. I see 3n as my common factor, and so 3n times 16 minus n, so I do not have a difference of squares. See, I let that fool me. And I'm going to do the zero product property because this binomial is completely factored. 3n equals 0, 16 minus n equals 0. Divide by 3. See, here I didn't throw that out because I have a variable. I can divide both sides by 3 and get my variable alone. N does equal 0. I'll subtract 16 here. Negative n equals negative 16. Divide by negative 1. N is positive 16. So my two solutions here are 0 and 16. And on to the last one. It does not equal 0, so I'm going to subtract 16x and subtract 48. Now, how did I know on the problem number 20 to move the variables that and constant that were on the left to the right, and I did the reverse from this one? I will tell you why when I made that 49. The reason I did that is because the degree, the variable with the largest degree, I want to keep that positive. So I move these to that. This variable has the largest degree, so I'm going to move these to the left. So that's how you decide. You want to move all the variables to the, you want to move everything to the variable with the largest degree. So now I have x cubed plus 3x squared minus 16x minus 48 equals 0. I'm going to group the first two, the plus sign, group the second two. The first group has x squared in common, so that leaves me with x plus 3. The second group has negative 16 in common. That leaves me with x plus 3. It worked out. X plus 3 times x squared minus 16 equals 0. I am going to factor this binomial. It is a difference of squares. Bring down the first one. Two empty binomials, one with an addition sign, one with a subtraction sign. Take the square root of x squared. Take the square root of 16. Do the zero product property. Subtract 3. Negative 3 is one solution. Negative 4 is another solution. And positive 4 is another. So my solutions are, and I always put them in order. I tried to always put them in order from smallest to largest. Negative 4, negative 3, positive 4. Have a great day.